All right, well, good morning, everyone. Welcome back to another exciting day in mathematics. Woo, woo. All right, so warm-up number 73 is on your screen. Let's get started, please. Today we will need a Cornell note with a Freyer model. We're moving on. So copy numbers 1 through 4, see how you do with those, and go. All right, let's see. Get us started with sum. Jaden, what'd you get? 4 plus I. That is correct. Pass them one. Who? What was that? I'm sorry. Okay, we'll come back to you. Product. What'd you get for the product? Pass someone. Negative 2 plus 9i. That's what you said? Okay. Let's double check that. 1 times 3, that's 3. Yeah, product. Oh, okay. 23 plus what? 19i. Let's double check. 1 times 3 is 3. 1 times negative 4 is negative 4i. 5i times 3, that's 15i. And 5i times negative 4i, that's negative 20i squared. All right, combine like terms. This becomes 11i. Is that correct? Then we got 3, and the negative 20 multiplies negative 1, because we substitute for the I squared, yes? So this is 20 plus 3, that's 23, yes? So just the 11 becomes, the 19 becomes 11. All right, thank you. And back to the difference. Negative 2 plus 9i plus 9i. That is correct. All right, let's go to number 2. Solve the quadratic equation. So for this one, I'm going to go ahead and work that one out just in case some of you had a little bit of problems. So I'm going to first set it equal to 0. X squared minus 4x minus 6 equal to 0. So for this one, let's see, can we factor it to make it simple? Let's see. Negative 6, negative 4. What factors of 6 add up to negative 4, guys? Anything? No, we can't use this. So we can't use factoring. We can't use square roots because this is not a binomial. So what's the next method that you guys want to try? What are the methods, Jose? What method do you want me to use to solve that? We can't use square roots. We can't use factoring. We can graph it, but there's also completing the square or quadratic formula. All right, completing the square. So that means we need to eliminate the constant. Plus 6 plus 6. We end up with x squared minus 4x. Empty space equal to 6. I need to complete the square right here. What do I add, Jose? Negative 4 over 2 squared, yes. Add negative 4 over 2 squared. So we end up with x squared minus 4x plus 4 equals 6 plus 4, which is x squared minus 4x plus 4 equals 10. Now we can factor the left side. So square root of the first, square root of the last, sine of the middle, squared, and all that equal to 10. Continue, Jose. What do I do? Square root to both sides. We end up with x minus 2 equals plus minus square root of 10. I'm going to continue over here. We got x minus 2 equals plus minus square root of 10. What do I do from there? Frida. Add 2 to both sides, so we end up with x equals 2 plus minus square root of 10, and those are my solutions. That is exact. If I was to ask you for an approximate, we would find the decimal equivalent of square root of 10. Pretty good. Bless you. All right. Number 3. Let's see. Help me graph that, please. Frida, pass someone. All right. Let me get this set up. So, Valente, how do I graph f of x equals x squared? Tell me points. Uh-huh. 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 Thank you. So that is f of x equals x squared. I'm going to label that f of x. Now they want us to do the transformation. So I'm going to write my rule first. G of x equals, and substitute all the values. For a, I'm going to substitute 1 times f, 1 over 1x, minus 5 squared, and then at the end, minus 7. So if you look at it, guys, the 1 here for a and 1 over 1 becomes 1. That doesn't do anything to the graph, but we do need to move it. So tell you where we're going to move it, and Valenta's going to pick someone where we're going to move that whole thing to. Okay, Valenta, pick someone. Not here. 5 to the right, 7 down, and my new vertex, with that said, is 5 to the right, 7 down. It's 5, negative 7. So at 5, negative 7, that's going to be my new vertex. So this one, this right here, moves over there, so it's going to look something like that. And that's my GX. Hands, have you got something like that by yourself? Okay, good. All right. And the last one. Substitution. I'm going to go a little bit faster on this one just for the sake of time. The first one, y is equal to 2x plus 3. So for the second, instead of writing y there, I'm going to write 2x plus 3. And then we set that equal to x minus 2. Get all variables to one side, so I subtract x. I end up with x plus 3 equals negative 2. Last, I subtract 3. So x equals negative 5. Am I done? No, I barely found the x value. I need the y value. So I'm going to use any equation. I'm going to use the bottom one. So I'm going to write y equals blank minus 2. but instead of the blank, I'm going to use what value for x? Negative 5. So y equals negative 7. So that goes right there. This is my solution. And what does that mean, guys? Let's see if you remember from yesterday. Tell your neighbor what that means. What is this point if we were to graph the two equations? All right. Let's see if you get the point. Diego Rosas, what is that point? Where the graphs intercept, yes. If we were to graph these two, that's the point where they're going to intercept. All right? So, thank you very much. Copy the agenda for today. Warm-up number 73, complex numbers. And your home plate for tonight, pages 133, 134 only. It's already on Canvas. Now, some of you, somehow you get confused. Once again, we are in what module? Quadratic equation. So go and look for the module, quadratic equation. That's where you're going to find the home plate. And while you're doing that, go to Canvas, turn in last night's home plate, please, and get a Cornell note ready. It is going to go super fast. We're moving on. We're still under the same umbrella of quadratic equations. We're just going to add a couple more things today and continue building up on that. So once again, last night's home plate was page 122, numbers 14 through 16. Turn that in and get a Cornell note for complex numbers. So here we go. Our objective for today, I can define and compute complex numbers. I can define and compute complex numbers. So what is our main concept for today, everyone? Complex numbers. So yes, what are they? Complex numbers are numbers that contain one real number and one imaginary number. Numbers that contain one real number and one imaginary number. Numbers that contain one real number and one imaginary number. Examples: 5 plus 3i, 12 minus 6i, 2i, square root of negative 8. All right? So it says numbers that contain one real number in blue. So look at the first example, 5 plus 3i. That means the 5 is a real number. Okay. Which means what? That the 3i is the imaginary. All right. Second example, the imaginary is negative 6i, which means the real number is 12. You're like, Mr. Q, come on, crank it up. All right. Look at the next example. What's missing here, everyone? A number. So what do you think the number would be, our real number, if it's missing? Very good. 0. Yeah, 0 is our real number, which means the other one is our imaginary. Next, what do we get from a negative square root, everyone? An imaginary, but we're still missing a real number, so we just plus 0 as our imaginary. As our real. Pretty straightforward, yes? No confusion? All right, copy the non-examples. 23, Michael Jordan. X squared plus 3x plus 2, and negative 3 plus x equals 10. Tell your neighbor why those are not complex numbers. Everyone, why are those not complex? They don't have an I. No imaginary. So what would be our first hashtag that would make complex numbers, everyone? Yeah, imaginary number. Or hashtag imaginary hashtag. How about them apples? How about hashtag real plus I? And yeah, of course, we can't go without real, hashtag BAM. All right, we got this, yes? All right, so with that said, let's do some practice. Look up to the screen, don't copy that. Tell your neighbor which one's real, which one's imaginary, please. All right, so let's see. Which one's the real one, Jessica? 7, yes, that's our real. Now look at the symbol I'm going to use for real numbers. Look up. It's a letter R, but with 2 bars. That's the symbol for real numbers. So whenever I ask you to label something, just use that symbol. And of course, the second part is our imaginary. All right, we got this. So with that said, on your screen, label that next one. Example 1Q reads, identify the real number and the imaginary number. Once you label it on your screen, copy it on your paper, and then submit. Go. All right, looks like we got this straight. There it is. All right, here goes a tricky one. Let's see how you do with that one. Label the real and the imaginary. Go. All right, looks like we got the correct answer on the screen. There it is. Double check your work. All right. So from 1 to 5, show me your fingers. How comfortable are you with this? Yeah, we got this. Yeah. No problem. All right. So let's move on to funner stuff. How about this one? Copy this one. Example number 3. And today's the lesson that we're actually identifying that those are complex numbers, and we're finding the sum, difference, and product. And some of you are saying, Mr. Q, weren't we doing that on the warm-ups? Yes. I wanted to make sure that we actually knew what we were doing before we even got to the lesson. So we got example 3, find the sum, difference, and product of 5 plus 7i. That little arrow in between the two means and, parentheses, negative 2 plus 9i. So by now you should know how to do all 3 of them, yes? All right, get started, and I'll pick someone to help us out. Sum, 5 plus 7i plus negative 2 plus 9i. All right, Caleb, what is the sum for those?
3
Uh-huh.
plus 2.
Plus
16.
16i. Yes, that is correct. Thank you. Let's go to subtraction. We got 5 plus 7i minus negative 2 plus 9i. Pass on one, Caleb. Diego. 7 minus 2i. And for this one, for those that didn't get that, remember to distribute the negative here and here. That becomes 2 minus 9i, and then you combine with these. Thank you. Let's go to multiplication. Multiplication. We got 5 plus 7i times negative 2 plus 9i. All right. Help me with that one. Pass on one, Diego. Fredo, help me multiply this. 5 times negative 2. 5 times 9i. Ne 7 times negative 2. Negative 14i. And 7i times 9i. 63I to the second, yes. So if we combine the i's first, these, 45 minus 14, that should be what, 31I? Everyone, yeah? All right. However, don't forget, over here where the I square is at, we need to substitute what, everyone? Negative 1, yes. So 63 times negative 1 gives us negative 63. So negative 10 and negative 63, that is negative 73 plus 3I, and that's our product. All right. How we doing? Good? From 1 to 5, I'll confer you with these. 5 4s, 5 4s. Yeah, we've been doing this on the warm-ups forever. Send me your notes, see what you did. Forever. All right, example 3Q's on your screen. Negative 7 plus 3I and negative 3 plus 2I. Once again, find the sum, difference, and product. See how you do by yourself. Copy and go. All right, sum. Joel, what'd you get for the sum? Huh? Joel, couldn't hear. Sorry. Negative 10 plus 5I. That is correct. Pass someone. Difference. Started occurring here. Negative 4 plus I. Hands if you got that. All right, that is correct. Thank you. Multiplication. Pass on one, please. The what? Still doing it? All right. Let's see what you get for this one, Juan. Negative 15 plus what? 23. Let's go. 23I. Double check. Negative 7 times negative 3, that's 21. Negative 7 times 2I, that's negative 14I. 3I times negative 3, that's negative 9I. And 3I times 2I, that's positive 6I. So this becomes negative 23, that is correct, but it's in negative. And then we got 21 and 6, oh, this is I squared. 6 times negative 1, that's negative 6. And 21, that's positive 15. So it's 15 minus 23I. Hands if you got that. All right, we got this. All right, send me your work, see what you did. So I think we got problem number 1. Problem number 2, which is identifying the sum, difference, and product of complex numbers. That would be second part of the home plate. Show me your fingers how comfortable you feel with complex numbers so far. 5 4s, 5 4s. Okay, we got it. So we now move on to my next favorite segment. Let's go. So before I came to teaching, like I think I already shared with you guys, I was a mobile electronics specialist. I got certified by all the brands. You name it, I was certified. So who's heard of Pioneer? How about Alpine? Jensen? Rockford Fosgate? Any of those brands? Anyways. So all those brands sell electronics, and however, in those electronics, there's something that we call electric circuits. So the one you have in front of you, on the left side, you see the picture of a switch, a battery, and a light bulb. On the right side is the actual diagram that you would accompany that circuit with, so that people knew how to put it together. So if I was to ask you guys that I was hiring you guys to put together these kits, you would have actually put some of those diagrams in the baggie before we send them out on eBay. So why am I going with this? This is a very simple circuit, very simple. Let me show you more intricate circuits. Look at that one. Have you guys seen some of those? Yes? That is also very complex. That. And of course, some of you that don't know, we carry all of those in our cell phones. All the cell phones have circuits, like a bunch of circuits in between. So today I'm going to introduce you to 3 basic components of a circuit. So copy this table, please. For electric circuits, I'm going to give you a component and the symbol that we use for those components. So as you're making your table, I'm going to start with blue for the first circuit component, known as resistor. Resistor. Now you've seen these before, very practical, but sometimes it goes without, sometimes we don't really identify it, but the symbol looks like this. Now why is that? Well, you've probably seen it before. Let me draw over here on the side. Has anybody changed a light bulb? Have you guys noticed that it has a very thin wire right here? That is an example of what you can consider a resistor. And that's why we use that symbol as the resistor symbol. All right? So far so good? Yes, that's a cute. Let's go to the second one. The second one is known as an inductor. Inductor. I'm using that green for that. And the symbol for that one is very similar to the first one, but instead of going zigzag, it goes in circles. Like that. All right. Now before we continue, turn over here really quick so you can see. I have a pencil right here. Look up. Here's a pencil. Now you can do this at home, and I'm going to show you a quick experiment you can do. So at home, if you were to get a nail, does everybody know what a nail is? Yeah, when you nail stuff. Get a big nail and get a wire, such as this one, and look what I'm going to do. I'm going to wind this up like this. And what I just created is an inductor. If I was to put a battery to here and here, and if this was metal, it creates a magnet. You can do that at home. Just don't plug it into the wall, because that's 120 volts. I'm talking about like one of those squared batteries, or a little D battery or A battery. If you plug it in like that, it creates a little magnet. This is an inductor. Why, Mr. Q? Because check this out. If I was to run current from here to this side, it slows it down, all the loops. It slows it down. But with slowing it down, it creates here a magnetic field. Another way of putting it, have you guys been on the treadmill? Have you guys noticed after being on the same spot, when you get off, it feels kind of weird? Hello? Right? It creates that magnetic field. And that's why we use this symbol for inductor. Let's go! Let's go! All right? And the last one is known as a capacitor. Capacitor. And the symbol looks like this. And if you notice, it starts, and all of a sudden it stops, and then it stops, and then it starts. And the reason it's like that, because the the job of a capacitor is like this, letting electricity go by, but not letting it return. So look over here really quick. If I let electricity go by that way, in order for it not to return, I have to stop it. It goes one way, but then I stop it coming this way. That's why we use that symbol. Look at the symbol, look at my hand, right? It stops from coming back. And we use that in electronics a lot, especially, let's see, have you guys used your, you know how your family's vehicles have alarms where you click on the remote and the lights blink? So the alarm sends a little signal to the lights to turn on, but when when whoever's driving turns on the lights of their car, it doesn't send electricity back to the brain of the alarm, or else it would burn out. That's why we use a capacitor. Anyways, so those are the three that we're going to be talking about. So with that said, let's see how well. Look at those symbols. Resistor, inductor, capacitor. You got it? All right, let's give it a try. On your screen, label, don't copy that, label each component. See if you can do it without looking at your notes. All right, I think we got it. So look at your screen. Yes, we got it, yes. All right, but from now on, whenever I ask you to label it, look at your screen. Let's just use like initials. Like this one would be what? R, this one, I, and this one, C. So we can go a little bit faster, yes? All right, so with that said, copy that one on paper, please, first. You're like, oh, snap, I know, right? Let's go. Let's go. Copy that circuit first, and then we're going to label with letters what each component is. Copy that. So, make sure you label your diagram electric circuit, because like I said, once we get started with the mathematics of it, which is tomorrow, today's only just getting familiar with the symbols, we need to know this a little bit faster. So far so good, yes? From 1 to 5, how comfortable are you with these? All right, let's do one more. Here we go. Don't copy that one, just label it on your screen. Label it on your screen. 4, 3, 2, 1. All right. Correct answers on your screen. All right. So before you log out, here goes a quick poll. Very good. Thank you. Appreciate it. See how we doing. Yeah, so pretty much if you think about it, we did all the work on the warm-up. So the complex numbers, addition, subtraction, multiplication, we got down out cold. So make sure you work on that tonight on your home plate. I'll stop the video at that time. And peace.